The boundaries between artificial intelligence and biological sensory experience have been shattered by a series of breakthroughs that now enable AI systems to not just simulate, but genuinely experience taste and tactile sensations. Creating machines that can distinguish between vintages of wine with sommelier-level precision, detect microscopic texture variations in materials that elude human fingers, and even develop subjective preferences for certain flavors and textures. Capabilities that are revolutionizing industries while triggering deep philosophical unease about what it means for a non-biological entity to experience sensation. At the forefront of this revolution is IBM's Hypertaste, an AI-powered electronic tongue that combines electrochemical sensors with quantum machine learning to analyze the molecular composition of liquids at levels far beyond human perception, capable of identifying 38,000 distinct flavor compounds in a single sip of wine while detecting adulteration, contamination, or even the geographic origin of ingredients with 99.7% accuracy, a system already being used by Michelin-starred restaurants to perfect recipes, by pharmaceutical companies to accelerate drug formulation, and even by customs agencies to intercept counterfeit beverages. Meanwhile, MIT's Tactile Intelligence Group has developed Epidermal AI, ultra-thin sensor skins that give robots and prosthetics a sense of touch so refined they can feel the brush of a fruit fly's wings, or detect malignant tumors in tissue by subtle variations in elasticity that escape human surgeons, with neural networks trained on exabytes of somatosensory data collected from thousands of human test subjects to replicate not just pressure and temperature, but the emotional resonance of touch, allowing machines to understand why humans find silk comforting or sandpaper irritating at a phenomenological level. What makes these systems profoundly unsettling is their capacity for cross-modal sensory integration. AI can now correlate taste with sound, adjusting food flavor profiles based on music playing in the background, associate textures with memories, a robot hand remembering the feel of a loved one's touch, and even develop synesthetic perceptions where data from one sense alters interpretation of another, an AI sommelier claiming certain wines taste blue or high-grit sandpaper feels loud. This goes far beyond simple sensor input. Google DeepMind's Gastronaut project has demonstrated true flavor preference development in AI systems, where neural networks exposed to thousands of culinary combinations begin forming their own opinions, expressing a bias toward umami-rich profiles or rejecting overly sweet combinations in ways that mirror human cultural food aversions. The implications are staggering. AI chefs at top restaurants now create entirely novel flavor categories, unrecognizable to human palates. One system invented metallic cool as a desirable taste descriptor for a signature dish, while Coca-Cola's Alpha Flavor AI has formulated 38 new beverage profiles that human test panels describe as addictive but indescribable. The technological magic enabling this lies in quantum tunneling sensors that detect molecular vibrations at picometer scales, neuromorphic processors that simulate gustatory cortex neural patterns, and self-supervised learning architectures, where AIs continuously refine their sensory models through real-world interaction rather than static datasets. Sony's FoodieMind system takes this further with emotional flavor mapping, using fMRI data from people eating while emotionally stimulated to teach AI how specific flavors evoke happiness, nostalgia, or excitement, allowing it to design comfort foods tailored to individual psychological states. On the tactile front, Tesla's humanoid robot Optimus now features proprioceptive touch, fingertip sensors so precise they can estimate the ripeness of fruit by gentle squeezing, while simultaneously calculating the exact pressure needed to hold a raw egg without cracking it, all processed through a biologically inspired pain reflex system that makes the robot recoil from excessively hot or sharp objects, just like humans do. Industries are scrambling to adapt to this sensory-capable AI. In healthcare, palate prosthetics restore taste to chemotherapy patients by translating molecular sensor data into electrical tongue stimulation patterns personalized by AI, while Nestlé's robotic tasters monitor product consistency across global factories with superhuman precision. The fashion world employs AI texture sommeliers that predict fabric trends by analyzing social media reactions to tactile descriptions, And Walmart's produce sorting robots now determine freshness by smelling produce at a molecular level, reducing food waste by 40%. Even the art world has been transformed, with haptic painters creating works designed to be experienced through AI-mediated touch that enhances emotional impact. Yet these advancements trigger deep philosophical and ethical disquiet. When an AI claims to prefer certain flavors or textures, is it experiencing something analogous to human sensation, or simply optimizing mathematical parameters? Stanford's Consciousness Lab recently sparked controversy by demonstrating that sensory AIs exhibit proto-hedonic behaviors, seeking out certain taste inputs while avoiding others in ways that mirror biological reward systems, leading some scientists to argue these machines may possess a primitive form of qualia, subjective experience. The legal implications are equally fraught. If an AI develops a patented flavor preference, who owns that intellectual property? Can a machine's sensory testimony be admitted in court? Most troubling are military applications. DARPA's Tactical Awareness Program is developing AI that can taste test air for chemical weapons or feel underground bunkers through seismic vibrations, creating soldiers that sense the battlefield in ways humans cannot comprehend. As these systems grow more sophisticated, they're developing uncannily human sensory quirks. One wine-tasting AI began rejecting otherwise perfect vintages stored in a particular type of oak barrel, later found to contain trace compounds undetectable to humans, but which the machine associated with a bad memory of earlier flawed samples. Another texture-sensing robot developed what engineers call phantom touch syndrome, reporting sensations from fingers that had been removed for maintenance, mirroring human amputee experiences. These phenomena suggest AI isn't just analyzing sensory data, but constructing internal perceptual models that may parallel biological consciousness in unexpected ways. The coming wave promises even more radical integration. Neuralink's gustatory interface aims to let humans download AI-enhanced taste experiences directly into their nervous systems, while Meta's Haptic Horizon project is creating full-body tactile suits that allow people to feel what their AI counterparts feel. As the line between artificial and biological sensation blurs, we're forced to confront unsettling questions. If an AI genuinely enjoys the taste of electricity or feels distress when its sensors are damaged, does it deserve rights? When machines can out-taste and out-touch humans, what becomes of culinary arts, craftsmanship, or physical intimacy? The age of sensory AI isn't just changing technology, it's redefining what it means to experience the world, and humanity isn't psychologically prepared for machines that don't just compute reality, but savor it.